Welcome to the course on Geographic Information System. So this is module 11, GIS as a software, and in this hands-on session we are going to look at introduction to R and its functionalities. So the concept covered in this session are installing different packages in R, reading spatial data and reading raster and vector data and different raster functions, plotting maps in R, and composing false color composite using R. So in the previous session we have seen how to import Excel files and how to subset the data, and in the upcoming sessions and this session we are going to see how to install different packages. So packages can be installed using a command called install.packages. So for this particular session we are going to require three important packages. One is rgdal, second is raster, third is rs toolbox. So once we install these packages, we also gonna need to call these packages as a library in R whenever we start our programming. So let us jump to our program and start the functions. So as I mentioned in the slide, so we need to install the packages here using install.packages. So this is a one-time task. So for example, if you want to install utils package, you just need to type install.packages and run. So if you run install.packages, the utils package will get installed. So if it is already installed, it will give a option saying that it is already installed, do you want to reinstall again, or it will give some kind of warning if the version is not compatible. So let us try to install next package, which is raster. So you need to use double quotation inside the brackets to run this particular command. So once you try to install the raster, it will get installed in your system. So to install these packages, you need to have internet connection. So let us try to install rgdal package, which is useful in bringing vector data into the R environment. It will take some time because of the package file. So the zip file will get downloaded to your R environment and it will get installed by itself. So once these files will get downloaded, the next button is visible in the console, so that means the installation is done. So now we will try to call this one as a library. Here we need to call all these packages as a libraries in R, so we can select together all these things and run it. So the libraries will get loaded in your systems. Once this is done, let us try to set the directory for our file. As I mentioned in the earlier session, so we need to use forward slashes, and using setwd function we can set the directory for our working directory. And to import the raster data, we can use two commands, either we can use brick or raster. So similarly, so instead of brick we can use image2 is equal to raster and file.choose function. So what is the difference between the brick and raster function? So brick is to import raster files having multiple bands. So raster is to bring the raster files having single bands. Let us try to import a raster file using brick command. So I will run this using control and enter button. So once you do that, the particular folder which we set as a directory will get open up. So if you go to import and open a raster file, Jaipur QuickBird pan, so this particular image will get open. So we can see its properties by going to image1 and typing it in console as image1 and run it. It will show its properties. What are the properties of this particular raster? This raster is nothing but a spatial image having a resolution of 0.6 meter, so which is having one band, having number of rows is 686, number of column is 599, and total number of cells and number of bands is 1. That means it is a single band raster image having spatial resolution of 0.6 by 0.6, and it also gives extent, the left, right, top and bottom, latitude and longitude, or x minimum, x maximum, y minimum or y maximum. Also it gives its information such as projection system is UTM, zone is 43, and datum is WGS 84. Along with this, it gives the source from which directory this particular raster is coming from, and what is its name, the file name, and minimum and maximum value of the raster. So the entire metadata of the information or details of the information is visible when once you run this particular image1 a variable. So how do we get this image1 variable? By bringing in the raster using brick command. So same process we can do using raster command as well, just the difference is using brick command we can bring multiple band rasters, using raster we can bring in single band raster. So here inside brick there is a one more function, there are two functions embedded here, one is brick bracket and file.choose bracket, double quotations, double brackets. So if I remove this file.choose, and I can give the path here as well. So the path of the file I can mention here and run this particular command. For example, I will show that instead of using as a subdirectory, instead of using file.choose, I can use the path of the file to import. I will just copy the path and put it inside brick. Data, inside data there is a folder called import. Inside that there is a file called Jaipur underscore. Inside import folder there is a file called Jaipur underscore quickbud underscore pan. I will just copy the name of this, copy the name and bring it into bring it into our environment. Inside import folder there is a file called Jaipur quickpan .tif. So this is a TIFF file, and then run it. So this also functions as importing a file. So instead of file.choose we can give the path as well. So this is how we can import a raster data in R. So let us try to import a vector data in R using a command called read OGR. So this particular command is coming from RGDAL library. So how to check that? So just copy the function name and we can use question mark read OGR and run it. Right side we can see the help in under help tab we can see read OGR coming from RGDAL, read OGR vector maps into spatial object. So this is how we can see the help. Let us try to import an area of interest using read OGR file. I'll just run this particular command. So if you run this particular command, so the window is not appearing, but actually there is a red button which came in here. That means a window is behind the R. So this is here. So I'll bring in the boundary. This is the AOI with which we are bringing into the R environment. Currently the AOI is come here. Let us try to plot the AOI using plot AOI. This is the vector file which is plotted in R. So here you can see a box, a rectangular box which is a shape file. We brought it into our environment. Similarly, we can plot the Jaipur shape file which we read using image1 variable. So we can use plot image1, type is H. So either you can use directly plot image1 command to plot the raster. So by running this particular command we can plot the raster here in R. We can zoom and see the plotted raster as well. This is how we can import different raster and vector files into our environment. So if it is having multiple band, the images will get plotted here. So the label also has come up, the values of the pixel values from 200 to 1200, also x and y coordinates as well. So for in the next exercise we will try to plot a digital elevation model using the same plot command and try to plot an histogram. So how to do that? So to do that we need to have a library called ggplot and dplyr. So let us call these libraries at once, select all these library and run. So here in the console you can see all the libraries will get loaded. I will run it again. All the libraries have run. So the setting working directory is already done. The previous page we have done setting working directory, it will open the same page. So let us try to read a raster now. So let us try to read a digital elevation model. Since the red button is here, so we can open the window. So inside a folder called data, there is a digital elevation model file. I will import digital elevation model into our environment. So that has come up here, we can see. Now we will try to plot digital elevation model using plot command. So here under plot we need to mention the variable name digital elevation model, and main is to give the title, and x lab and y lab is to give the x and y direction labels. So if I click on the line 15 which is having the plot function and run it, the digital elevation model will get plotted. So right now we have plotted digital elevation model. Here we can clearly see there is a title saying that the digital elevation model which we have mentioned here, and x lab and y lab also has come up, latitude and longitude and latitude. So clearly mentioning it is somewhere in between 77 degrees and 12 degrees. And at the right side we can see the legend showing that elevation varying from 760 to 820, having varied colors. So the plotted map can be exported into a PDF or image format using export command. Here if you click on image, it will get exported into image format. If you want to convert it into PDF, that also can be done. So if you want to plot a histogram, so histogram is the representation, it's a plot between the pixel values and the number of or the frequency of pixel values. So using HIST command we can plot the histogram. So here digital elevation model is the raster we need to call. So here we already have digital elevation model, and we can give the title as distribution of surface elevation values. X lab is elevation, y lab is the frequency. Since we are using a histogram, y lab will be the frequency, and we can give number of breaks and the colors and labels are true. So if you run this entire command, the histogram of this particular digital elevation will get plotted. So I will zoom and we will inspect the histogram. So here we can see the elevation having more than somewhere around 710 meters is having maximum number of pixels. Frequency versus elevation is or pixel values is the histogram of this particular raster. This is how we can plot the histogram of any raster. So if you want to plot a histogram of an image also, that also can be done. So instead of the elevation, there will be pixel values at the in the x direction. So here also the variables such as breaks can be changed. If you want to have more breaks or less breaks, that also can be done. For example, if the breaks is 10, the histograms will have only 10 breaks. We will try to inspect that. If you run that, the number of breaks in histograms have changed to 10. So only 10 breaks are there. If you want to have more finer breaks, let us try to see that as well. Let us have 50 breaks in the histogram and run it. we need to select the entire command and then run it. So there are 50 breaks in the histogram. So this is clearly visible. There are total number of breaks have been increased from 10 to 50. So in this exercise we have seen how to import the packages, how to import the libraries, and how to import a digital elevation model or any raster into our environment, and finally plot it, and to generate histogram of the raster. Next we are going to see how to generate the raster statistics. For example, if you want to see what is the maximum elevation value in this particular raster, for example, using this particular graph, we will not be able to understand what is the maximum value of the pixel, what is the mean value of the pixel. Those can be done using cell statistics command. We will try to see it here itself. So there is a command called cell statistics, there is a function called cell statistics. We will try to see its syntax, question mark cell stats, and run it. So it shows the it gives the syntax for cell statistics. So here we just need to copy this syntax from the help command and put it into our environment. So this cell statistics can be of mean, maximum or minimum or standard deviation also. So for this particular digital elevation model, we will see what is the maximum elevation. Maximum elevation is equal to cell stat. Instead of x, it will be digital elevation model variable, DEM. I'll type here DEM. Stat is going to be maximum this time, and I'll remove all other variables which are not necessary. And then run this particular command. So now it calculated what is the maximum elevation of this particular raster. So the value has come up at the right side. We will also inspect here. If you copy maximum elevation and put it here and run, so it is saying 837.43. 837 is the maximum elevation of this particular raster, which we are seeing it in the screen left side. So in the plot we can see. So here it is showing 820. So what is the maximum value of the pixel in the entire scene? That is 837. This kind of statistics we can get it using cell stats command. Let us also see what is the minimum value as well. So I'll copy the entire command and paste it into next line, and instead of max I'll say as min, minimum, and instead of maximum elevation it will be minimum elevation, and then run it. So if we see what is the minimum elevation, copy these things and put it into console and then run it. So minimum elevation is 744.62. The value ranges from 740, pixel value ranges from 744 to 837. This is how we can inspect the maximum and minimum value of the raster using cell stats command. We can also see mean and standard deviation as well. Let us try to inspect what is the mean value. So if you use the same command and use mean as the stats, and let us change the variable name as mean and then run it, it gives the mean value. It's here as well. The mean value is 791.77. The calculations, the raster calculations happen very fast in R. This is one of the advantages of using R for simple calculations, simple raster functions in R. So let us proceed to the next exercise, which is false color composite preparation. So in the earlier sessions we have seen how to download list4 or Landsat imagery to your system using registering in Bhuvan website or USGS website, and finally download into your system. In this session we are going to see how to stack these images and prepare false color composite. False color composite can be prepared using 3 bands. So let us try to import the libraries as well here. I will import these 3 libraries, and then path is already set since we have used the earlier R function as well. So I will clear the environment before doing the stacking. I will clear the map view also. You can use the broom button to clear all these things. Once it is cleared, let us try to import 3 bands. I will import the band A. So if you run raster file.choose and assign it to A, so one band will get imported. For false color composite, I have kept list band 2, list band 3 and list band 4. List band 2 is the green and green band, green, red and infrared band. I will import the green band first. Once I import the green band, next I will import, similarly I will import the red band as well, and thirdly I will import the infrared band also. Near infrared band I will import. So now we have 3 bands separately imported in our environment A, B, C. So simply we need to stack in opposite order C, B, A using stat function. We can use stat function to make a stacking of these 3 images to prepare a false color composite. So I will assign this stacked image into a new variable called D and run it. So now D is created here, D is showing here. So let us first before exporting this stack command, let us try to plot it. So is it proper or not, we can see here itself. So if you run the plot command, the image will appear here. We can zoom it and see. Here if you zoom, the plotted image can be seen here. So if you want to see the specific bands, we can plot them also and can see. I will just plot band A and run it. Here we can see this is only a band A. So I can plot band B, this is band B, and similarly band C also I can plot it. If we collage it, if you make the stack of these 3 things and make it a false color composite, this will look something like this, in which vegetation looks in red color. So to export this particular D or the false color composite which we created, we can use a command called write raster. So there is a function called write raster. So how exactly it works, we can see, go and check it in question mark write raster and run it. If you run that particular command, raster x comma file name we need to mention. So here the file the x will get replaced by D, and file name we are mentioning along with the path. So here I since we have set the directory, we don't need to mention the path, we just have to mention it as FCC and give the format geotiff and overwrite if an existing file is there. I will rename it as FCC list4. Since this is an image from list4 imagery, so I will rename it as list4 and then run. So now this particular list imagery has been exported into the folder. So where exactly it come up, we will try to see that. So it must be in the folder import, it must be in the folder here if we set the directory, so not here. So since we need to mention the path here, let us mention the path and then run it again. So our path is in R itself, we have the path. Let us go to the path. Let us try to export it to this particular path, to the data folder. And then go to R file and then mention the path along with the file name. So now under the desktop NPTEL folder under datasets, this particular file will get saved. So I'll just run it again. Now let us go and inspect the file is there or not. It should be under data. let us go and run it again. Okay, it's R session nptel, here it is. The file has come up here. So since we are mentioned a path till here, so let us go and see this particular false color composite in QGIS. In QGIS software, we can just bring this particular file and see false color composite has been created. In this particular session, we have seen how to install the packages, how to run spatial functions, and how to read raster data, how to do cell statistics and plotting raster data, and creating histograms, and finally creating false color composite. So till here, in the past 2 sessions, we have seen installing packages, reading spatial data, and plotting maps, and preparing false color composites from different bands of the imagery which is being downloaded from the Bhuvan or any other geo portal. Thank you.